In this lesson, we are going to learn how to find the limits of functions. So let's go ahead and then look at how you are going to do this. So I have the first example here, which is that the limit as x approaches 0 for the function x squared minus 25 divided by x squared minus 4x minus 5. So we've been asked to find the limit of this function here as x approaches 0. So all that this means here is that we are to evaluate this function here, assuming x equals what? 0. So when you have such question, the first thing you will want to do is to try direct substitution. Okay, so what you do then is that you are going to substitute 0 in place of what? X. Okay, so wherever you see x, you just put 0 there. So you're going to try the direct substitution and then see whether you will be able to find the limit of this function here. So let's look at that. So you're going to have 0 squared minus 25 divided by 0 squared, okay, minus 4 multiplying 0 minus 5. Okay, so let's simplify this. We're going to have minus 25 divided by 0 squared is 0, minus 4 times 0 is 0, and then you're going to have minus 5 here. So this negative will cancel out this, and then 5 goes into 25 5 times. Okay, so we're going to have this to be equal to 5. So therefore the limit of this function here is 5. Okay, so for this case, we are able to evaluate the limit of the function by direct substitution. Let's look at another situation. So you have the limit as x approaches 5. Okay, for the function x squared minus 25. It's that same function, but we are approaching a different value. All divided by x squared minus 4x minus 5. So we have another question here. Okay, the same function, but we are approaching a different value, which is 5 here. So let's try the direct substitution for this function also. So I'm going to have 5 squared minus 25. Okay, all this divided by 5 squared minus 4 multiplying 5 minus 5. So let's simplify this. We're going to have 5 squared is 25. Okay, that's like 5 times 5 minus 25. So all this divided by 5 times 5 will give us 25 minus 4 times 5, that's 20, and then minus 5. So then we are going to have 0 divided by 0, which is indeterminate. Okay, so you can consider this to be the limit of this function. So we see that over here, after trying the direct substitution, it didn't work, right? So we will have to find a simple way, or we will have to find another way to simplify this function first before we use the direct substitution method. So let's look at how you're going to do this. So to do this, I'm going to simplify this function here. Okay, so I'll try factorizing the function here, and then we look at what we can do next. So with this function here, I'm going to factorize the common. I'm going to bring out the common factors. Okay, so let's look at how that is going to be. We're going to have the limit as x approaches 5. Then for the numerator, you can see that you have difference of 2 squares here. I can write this as x squared minus 5 squared. Okay, it will give me the same thing that we have there, divided by, and then you have, then for the denominator, you have x squared minus 4x minus 5. Okay, so what I'll do is that I will factor this function here also. Okay, so let's look at how that is going to be. So I'll consider the value you have in the middle here, and then I will write it as a difference. Okay, so I'm going to write this as x squared plus x, okay, minus 5x minus 5. So you see that what you have here is the same thing I have here. Okay, if I add x minus 5x, it will give you minus 4x. Okay, so I just wrote this minus 4x here as a difference. Okay, so from here we can do some factorization here. Okay, so over here I'll factor out the x. I'm going to have x into bracket x plus 1, and then over here to have minus 5 into bracket x plus 1. Okay, so you're going to have x plus 1 and then x minus 5. So this is what we have. Okay, so now let's write that as the denominator. So you're going to have x plus 1 and then x minus 5. So now let's focus on the numerator. Okay, let's look at what you are going to do there. So we know that if you have an expression of this form, a squared minus b squared, you can write this as a minus b multiplying a plus b. So I'm going to do same to the numerator here, okay, which in this case you have x squared minus 5 squared. So you're going to have x minus 5 and then x plus 5. So let's rewrite the numerator. So I'm going to have the limit as x approaches 5 to be, that's for the function x minus 5 and then x plus 5. Okay, so let's divide this by x plus 1 and then x minus 5. So this is what you have. So at this point you can cancel out the common factor. So this x minus 5 will cancel out this x minus 5. So I'm going to have the limit as x approaches 5 to be x plus 5 divided by x plus 1. So at this point we can try the direct substitution and see. So I'm going to have 5 plus 5 divided by 5 plus 1. So I'm going to have 10 over 6. Okay, I'm going to have 10 over 6 here, and then 2 go here 3 times, and then go here 5 times. So I'm going to have the limit to be 5 over 3. So that will be the limit for this function. Okay, so let's try our hands on another example. Okay, so we take the third example. So you have to find the limit of this function here as x approaches 3. So the first thing we will do is that we will try the direct substitution method and see if it will work out. So let's look at that. So I'm going to have 3 squared plus 7 minus 3. Then this divided by 3 plus 3. Okay, so this is what you have now. So let's simplify it. So I'm going to have 3 squared will give us 9. So you have 9 plus 7 minus 3 divided by 6. So 9 plus 7 will give us 16. Which have the square root of 16 minus 3 divided by 6. And then the square root of 16 will give us 4. So you have 4 minus 3 divided by 6, which will result in 1 over 6. So you see that for this function, you will be able to find the limit by using the direct substitution method. Okay, so let's try our hands on another example. Okay, so we have the limit as x approaches 0 for the function square root of x plus 1 minus 1 divided by x. Okay, so let's try the direct substitution for this method also. When you have something like this, okay, when you have fraction, the first thing you should check is the denominator. Okay, you should check whether the denominator is not 0. And you know, for this to be possible, the denominator must not be 0. Okay, so you see that if you do the substitution, you're going to have 0 plus 1 minus 1 divided by 0, and then this will give us 0 by 0, which is indeterminate. So you will have to find a way to find the limit of this function here. So let's look at how you're going to do this. So to find the limit of this function here, you will have to rationalize the function. Okay, you have to rationalize what you have here. So let's look at how you're going to do this. So I'm going to consider the function x plus 1 minus 1 divided by x. So I'm going to multiply by the conjugate of the numerator. Okay, so that would be x plus 1 plus 1 divided by square root of what? X plus 1 plus 1. So what I just did was that I was multiplying by the conjugate of what you have here. So I just changed the sign which was in front of the negative. Sorry, I just changed the sign which was in front of the 1 here. So you see that over here the sign was negative and then I made it positive here. So that's how you write the conjugate of this square root of x plus 1 minus 1 here. Okay, so let's look at how we're going to do this now. So to simplify this, okay, the easiest way to do this is to simply group this. Okay, let's do this here and then let's square these two terms. Okay, so when I square these two terms, this squared here will cancel out this square root. So you're going to have x plus 1 and then minus 1 squared is still 1. So this divided by x multiplying the square root of x plus 1 plus 1. Okay, so you're going to have something like this. Okay, so you see that this negative 1 will cancel out this 1 here. So you're going to have x over x multiplying the square root of x plus 1 plus 1. And of course, we can cancel out this x here also. So you're going to have 1 over the square root of x plus 1 plus 1. So now let's rewrite this expression here. So you're going to have the limit. So you're going to have the limit as x approaches 0 for 1 over square root of x plus 1 plus 1. Okay, is this function here that you have transformed to what you have here? So now let's try the direct substitution and see what will happen. So you're going to have 1 over the square root of 0 plus 1 plus 1. So that's going to give us 1 over 2. So that will be the limit of this function here. So this is how to go about this type of questions. Okay, so let's take one more example. Let's take one more example. So let's find the limit of this function here. The limit as x approaches 3. Okay, for this expression here, square root of x plus 1 minus 2 divided by x squared minus 9. So let's try the direct substitution and see what you get. So I'm going to have the square root of 3 plus 1 minus 2 divided by 3 squared minus 9. Okay, when I simplify this, I'm going to have the square root of 4 minus 2. So that will be 2 minus 2 divided by 9 minus 9. This will give us 0 on 0, which is indeterminate. So that means we'll have to find a way to simplify the expression so that you can find its limits. So to do this, you are going to do same thing I did to the previous question. Okay, so you are going to multiply both the numerator and the denominator by the conjugate of what you have on top. So that's going to be square root of x plus 1 minus 2 divided by x squared minus 9 times, let me write this here, x plus 1 minus, okay, so in this case it's going to be plus, sorry, because I'm multiplying by the conjugate. Okay, so that will be divided by x plus 1 plus 2. So let's look at how I'm going to simplify this. So to simplify this, as for the numerator, it's very easy. So you can just do something like this and then square the numerators. Okay, so after squaring the numerators, you're going to have x plus 1 minus 4. Okay, this square there will take out the square root and then 2 squared will give us what? 4. So that's what you have here. Then let's look at the the denominator. So you're going to have x squared minus 9 multiplying square root of x plus 1 plus 2. So now this will be simplified to x minus 3, and then you have x squared minus 9, and then square root of x plus 1 plus 2. So now let's look at what we have here. I can write this as x squared minus 3 squared, and you see that again you have difference of two squares here. So we are going to rewrite this as x minus 3 x plus 3. Okay, so now let's rewrite the whole expression. So we're going to have x minus 3 divided by x minus 3 multiplying x plus 3, and then also multiplying the square root of x plus 1 plus 2. So at this point, we can cancel out the common factor here. We can cancel out x minus 3 here. So we're going to have this to be equal to 1 over x plus 3 multiplying the square root of x plus 1 plus 2. So now we are going to have this to be the limit as x approaches 3 for 1 over x plus 3 multiplying square root of x plus 1 plus 2. So at this point, let's try the direct substitution and see if it will work out for us. So I'm going to have 1 over 3 plus 3 multiplying the square root of 3 plus 1 plus 2. So let's simplify this. I'm going to have 1 over 6 multiplying, this will give us 4, right? And then the square root of 4 is 2. So I'm going to have 2 plus 2. So I'm going to have 1 over 6 times 4. And then that will give us 1 over 24. So that will be the limit for this function also. Okay, so I said this was the last question, but let's try one more. Okay, so I have the last question here. So let's find the limit as x approaches 0 for the function square root of x plus 4 minus 2 divided by x. Okay, so now you see that when you try direct substitution, you are going to have division by 0, and then that will give us an indeterminate form. So for that reason, let's try to simplify this. So we are going to multiply by the conjugate of the numerator. So we are going to have square root of x plus 4 minus 2 divided by x multiplying x plus 4 plus 2, okay, divided by square root of x plus 4 plus 2. Okay, so this is what you have now. So you know that for us to multiply what you have on top, just have to square the terms here. Just have to square these terms here, and then we get what we need. So let's look at that. So we are going to have, I'll just square this. I'm going to have x plus 4 minus 4, right, divided by x multiplying the square root of x plus 4 plus 2. Okay, so this is what you have now. So you see that you have 4 minus 4 here, so that's going to give us 0. So you're going to have x over x multiplying square root of x plus 4 plus 2. So this x will cancel out this x, and we are going to have 1 over the square root of x plus 4 plus 2. Okay, so now let's rewrite the expression. So I'm going to have the limit as x approaches 0 for 1 over the square root of x plus 4 plus 2. So at this point, we can try the direct substitution. So I'm going to have 1 over the square root of 0 plus 4 plus 2. Right, so I'm going to have 1 over the square root of 4, which is 2. So that will be 2 plus 2. And then I'm going to have 1 over 4. So that will be the limit for this function also. Thank you very much for watching this video. Please make sure you like and subscribe.